Good morning. This is data engineering lab, and today target is to understand the first lab experiment. This is the first lab experiment, identifying the data sources, list all potential data sources, evaluate the relevance and reliability, document the data source, obtain access credentials. The tools to be used are data source documentation templates and access credentials. So in data engineering, everything begins with data. So that's why we are starting with data source identification, then further steps. So coming to the first experiment, identifying the data source, let us look at it. Now the first step in identifying the data source is list all the data sources. Okay, so it's a huge list, so I'll just highlight the important ones. The first data source is databases. If it is relational databases, then you have MySQL, Oracle, PostgreSQL. For NoSQL, you have DynamoDB, MongoDB, Cassandra as example. If it is a data warehouse, you have Amazon Redshift, Azure Synapse. If it is an API, you have JSON, XMLs. If it is files, you have CSV, Excel, JSON, XML, text, Parquet, RO, ORC files, which are used for columnar storage files in big data environment. If it is cloud storage, you have Amazon S3 for object storage, Azure Blob storage. You have Google Drive, Dropbox, OneDrive as the example of cloud storage for files. If it is streaming data, for message queues you have Kafka, and you have RabbitMQ, you have Amazon SQS. For real-time streaming you have Kinesis, Apache Storm. Web scraping, you have data extracted using the library Beautiful Soup, Scrappy. If it is web pages, HTML pages. If it is web applications, you'll be extracting data from web-based forms and reports. If it is ERP, CRM data, ERP stands for Enterprise Resource Planning and CRM stands for Customer Relationship Management, then you'll be extracting data say through Oracle ERP or Zoho CRM. Logs and events data, they'll be application logs, web server logs, events, actions, audit logs. If it is IoT devices, from various sensors you'll be extracting the data, or industrial IoT home devices. If it is social media, you'll be using the APIs to extract data from Twitter, Facebook, RSS feeds, public posts you'll be using. If it is emails, then Gmail, and if it is messaging platform, WhatsApp, you'll be extracting data through APIs. Big data platforms, HDFS, Google Bigtable, Amazon Redshift, Spectrum. If it is legacy systems, COBOL based. If it is graph based databases, you have Genus Graph or Amazon Neptune. If it is data lakes, then you have Azure Data Lake for distributed file system. For data lake storage, you have Amazon S3. Spreadsheets, you have Google Sheets and Microsoft Excel. Public databases, you have government data sets, research data sets like Kaggle, UCI. Business intelligence tools, you have Tabla, Power BI. Data will be extracted or reported, exported from them. Custom applications, you may be having your own internal applications, your mobile data may be there. Now, this was the first part of the experiment. What was the first part? Listing all the data sources. Now, coming to the second part, evaluating the relevance and reliability of every data source. So, we'll go through few of them. So, say for example, you have databases. What are the examples in the databases we have taken? The examples in the databases we have taken as MySQL, PostgreSQL, MongoDB, Cassandra, Azure Synapse, Amazon Redshift, right? So these are our databases. Now, the relevance for the databases is very high. They are structured, they have transactional historical data. The reliability also is very high because they are well maintained using RDBMS and NoSQL systems. They have strong backup and recovery mechanisms. I'll take not all but few of them. Say for example you have cloud storage. The relevance is very high. They'll be using scalable storage and you have access to large data sets and backups. Reliability also is very high because Google Cloud Storage, Amazon S3 will be having strong SLAs and redundancy. If it is streaming data, again relevance is very high because they'll be used for real-time analytics, event-driven processing. The reliability is also high as they will be using platforms like Kafka, but they have a challenge in the form of data loss and processing failures. Say for example web scraping, the relevance varies. Okay, if it is market research, it is highly relevant. Competitive analysis or aggregating public data, this is highly relevant. Reliability, because you are extracting from web, the reliability can be low to moderate. Okay, as it totally depends on the website structure and it can change without notice. We'll take not all, let us take few of them. Let us say IoT data is there. Relevance is very high because for manufacturing, healthcare and smart cities or any industry, relevant industry, sensor data is very crucial. Reliability is moderate because IoT data can be prone to loss, latency and inconsistency due to connectivity issues. Social media data relevance is moderate to high because for sentiment analysis, for marketing, for customer engagement, but the reliability again is moderate because the nature is unstructured and you have biases, you have inaccuracies. We'll take few more. Data lakes, let us say. The relevance is very high as organizations need to store large amount of raw data for future analysis. Reliability is moderate to high because data lakes are scalable and data quality and consistency is very challenging. So you have high relevance for these databases, APIs, ERP, CRM, streaming data, cloud storage, big data platforms, third-party data providers, BI tools. Low to moderate legacy systems are there. Moderate files, logs and event data. Moderate to high you have IoT devices, graph databases, data lakes. Now the third task is documenting the data source with detailed information. Hope you remember the flow here. The first part of the experiment was listing the data sources. The second part of the experiment was evaluating the relevance and reliability of every data source. The third part is documenting the data source with detailed information. Okay. Why you need this documentation? Because people who are involved in this, they should understand from where the data is coming from, what is its structure, how to access it, any constraints are there, and so on and so forth. The template for documenting the data source can be, you can mention the type of the data, description, owner, access method, data structures, frequency, volume, data sensitivity, reliability, relevance, constraints, okay, link to any existing documentation, data dictionaries, so on and so forth. Let us take an example of, say for example, MySQL database. Okay, the type is relational database. Description is, say for example, it has customer data, customer information, whatever it is. Who is the owner? So maybe the database administrator, maybe the department. What is the access method? You will be using MySQL connection strings, credentials are required for that. What is the structure? It has tables, okay, it has various fields. What is the frequency of updates? real-time transactions. What is the volume? Maybe 10 million records, 50 GB, whatever is there in that customer data. What is data sensitivity? It is very high because it has PII, personally identifiable information. Reliability is very high because it is backed with redundancy. Relevance is very high because it is critical for customer analytics and reporting. Constraints, so you may have access restricted to only restricted people. You have some SQL query limits to prevent performance degradation. Okay, so documentation may consist of data schema and database access guide like that. So we'll take one or two more. Let us say I take Amazon S3, okay, and it has say campaign data. The type of storage is cloud storage. Description is whatever marketing related information is stored. Who is the owner? That particular administrator. What is the access method? You will be accessing it through S3 bucket URL, okay, and for that you need to have IAM credentials and permissions. What is the data structure? It has various formats, maybe CSV, maybe JSON, maybe Parquet. Frequencies of update ad hoc, okay. So depends on that because this is used for campaign, right? So maybe after every campaign it is updated. Volume varies, maybe MBs to GBs. Sensitivity, okay, moderate. It has strategic information but no PII. Reliability is very high because it is backed by AWS robust infrastructure. Relevance is very high because it is very much essential for analyzing campaign effectiveness and ROI. Constraints, you need to have access control policies so that unauthorized access are avoided. Documentation, it has S3 bucket configuration and marketing data guide. So like that, you will be having this detailed info. Now, coming to the fourth part, obtaining the access credentials and permissions for data sources. Okay, this is a very critical step in every ETL process. What are the steps to obtain the access credentials and permissions? You need to identify the owner. Okay, you need to send the request. Okay, then you need to document the access request and you need to identify what kind of access is required. Okay, say read only or write only or API. You need to specify environment, server from where you need this. So, okay, you also need to have complete required documentation, terms and conditions. You need to fill out the forms. You need to provide the justification. You need to set up the access control. You need to implement security best practices. You need to coordinate with the IT and security teams. You need to have a test access initially. Once everything is proper, maybe permissions, verifications are done, then you can go for it. Okay. You can obtain access credentials and permissions for every data source. For example, if you have MySQL data, you identify the data DBA, database administrator, contact him. Okay. You specify what kind of access you require. You submit the access request. Then the DBA will be providing you the username, password, and connections. For test access, you may be using MySQL workbench to confirm whether you received the required request. So like that, this is the fourth step of the instruction or our assignment. Now coming to the last part, from where you can get your data from internal data sources, reviews, metrics, demographic and feedbacks, finance and human resource, from external data sources like government publications, social media, publicly available databases, news media, web scraping, third-party data providers, transactional data sources like point of sales, e-commerce platforms, IoT and sensor data, experimental data sources, historical data sources, geospatial data sources. You can refer websites like Kaggle and UCI for these kind of data identification. Thank you.